Let's now look at a typical problem about finding derivatives of inverse functions. In this problem, we need to do two things. First, we need to prove that the function is invertible, and then find the function's inverse derivative at a point. Here is at the point 3. Okay, so let's do the first part. How can we prove that a function is invertible? Okay. And if you look at this function over here, it's pretty complicated, but we talked about one technique we can use to show a function is invertible is to show that function's derivative is either positive or negative. If it's positive, then the function is increasing, and if it's negative, then the function is decreasing. So the function will be 1-to-1, and we have an invertible function. So we look at the derivative, and the function's derivative is going to be 2 plus cosine x. Okay, and we see that cosine x is always between 1 and negative 1. So we have 2 plus cosine x is greater than 0 all the time for all x. That means f of x is strictly increasing. So it is invertible. So f of x is 1-to-1 and thus invertible. Okay. Now we need to find its inverse derivative. We cannot solve the formula of its inverse because obviously we cannot solve an equation like y is equal to 3 plus 2x plus sine x. But we learned that if we want to find the inverse derivative at a point b, then we can find the derivative of the original function and evaluate at a if f of a is equal to b. So if we want to find the inverse derivative at a point 3, we need to find a point a so that the value of the function is 3. So we need to solve this one. 3 is equal to 3 plus 2x plus sine x. This is pretty easy to solve because we see over here that x must be equal to 0. That's the only possible solution. And then that means a is equal to a. That means a is equal to 0. So now we have f inverse derivative at point 3 is equal to 1 over the derivative of f evaluated at point 0. And we do the derivative of the original function. We already calculated that. That's 2. Derivative is 2 plus cosine x. And then we need to let x to be 0. Okay, and that will give us 1/3, and that's the derivative of the inverse function at point 3.